Today's lesson is on multiplying radicals. As usual, there is a video guide to go along with this lesson. If you haven't already printed the video guide, go ahead and pause the lesson, print the video guide, and then come back so that you can fill out the worksheet with me. So for multiplying radicals, there are 4 steps for us to be able to work out these problems. And we're going to go ahead and write those down together and then do several examples. All right, so step number 1 for multiplying radicals is that you need to rewrite the radicals as fraction exponents or rational exponents, okay? So rewrite the radicals as rational exponents. And remember from our last lesson, rational just means it's any number that can be written as a fraction. So we're going to be writing these exponents as fractions. The numerator is the exponent, the denominator is the radical or the root. Okay, so that's step 1, just rewriting. All right. Step 2, remember for multiplying with exponents. Okay, so this was a few lessons ago. When we were multiplying problems that had exponents, we actually added the exponents together. So just a quick reminder, if we had x to the 5th times x to the 3rd, we could write this out the long way and count and figure out, okay, there's 8 x's, or we can just add their exponents together. 5 plus 3, so the answer would be x to the 8th power. Okay, we're going to be using that same concept today, and that's why we're changing the radicals into exponents so that we can just add the exponents together. All right, so that's going to be step B. Okay, 4 different steps, A, B. B is going to be add the exponents. After you add the exponents, okay, step C, you need to reduce your fraction if possible, okay? So reduce if possible. Sometimes you'll be able to reduce it and sometimes you won't, okay? So if you can, great. If you can't, just leave it the way it is. So reduce if possible. And then our last step, step D, is to write your answer as an exponent. Now remember, rational exponents, do not write those as mixed numbers, okay? If it's an improper fraction, leave it as an improper fraction, okay? You do not have to convert those into mixed numbers. Actually, I don't want you to at all, okay? So those are the 4 steps that we're going to be using to solve the following examples. For problem number 1, we have the 11th root of x to the 4th, and we're multiplying that by the 11th root of x to the 6th. The first thing that I want you to do is to rewrite these as fraction exponents, rational exponents. So x is going to stay the same. We're going to have our fraction, all right? Exponent is the numerator, so 4 in the numerator. Radical is the denominator, so 11 as our denominator, so 4 11ths. And we're going to multiply that by x, and then our fraction. Exponent's the numerator, so 6. Radical's the denominator, so 11. So 6 11ths. All right, our next step, step B, is to go ahead and add these exponents together. All right, so we're going to have 4 11ths, and we're adding to that 6 11ths. Now, we are adding fractions, okay? Adding fractions in algebra. We can do this. So remember, for adding fractions, you must have a common denominator, okay? So looking at our fractions, conveniently, we already have a common denominator. So I can go ahead and move on. All right, if the denominators are already the same, remember the rule for adding fractions. You add the numerators. 4 plus 6 is 10. You keep the denominator the same. That's why they have to be the same, all right? If they aren't the same at the beginning, you can't keep them the same, okay? So keep your denominator the same. We've added the fractions, so step C, okay, our next step, 10 11ths. We we are supposed to reduce if possible, okay, which means I need to simplify my fraction. Well, 10 and 11, there is no common divisor there, so I'm going to leave it as 10 11ths. And then my last step is to go ahead and write this as an exponent, 10 11ths as the exponent for x. So x to the 10 11ths is our answer for problem number 1. Now, for problem number 2, we have the 9th root of n to the 5th, and we're multiplying that by the 9th root of n to the 7th. So first step, rewrite each of these with rational exponents, okay? So m stays m. For my fraction, 5 is the numerator, 9 is the denominator. We're multiplying that by m, and then for my fraction, 7 is the numerator, 9 is the denominator. Once you rewrite both of them with rational exponents, add the exponents together. Multiplication problem, you add exponents. So we're going to take 5 ninths and add to that 7 ninths. So we are going to look for a common denominator. Well, looking here, 9 and 9, they are already the same number. So they already have a common denominator, so I can go ahead and skip that step, which means go ahead and add. So we're going to add the tops together. 5 plus 7 is 12, and my denominator stays the same, so I have 12 ninths. After this point, we are supposed to reduce if possible. Okay, so looking at this, 12 and 9, there is a common divisor. Both of these are divisible by 3. So I'm going to divide the top and the bottom by 3. 12 divided by 3 is 4. 9 divided by 3 is 3. Looking at 4 over 3, there is no common divisor for 4 and 3, so it's simplified as far as we can. So now I just rewrite my answer as an exponent. So my m stays the same, and this is my new exponent, 4/3. So our answer is m to the 4/3 for problem number 2. For problem number 3, we have the 12th root of d, and we're multiplying that by the 3rd root of d to the 7th. So step 1, rewrite these as rational exponents. So we have d, and then we're supposed to have a fraction here. Now d does not have an exponent. Remember, every number or letter has an exponent of 1 if it's not written. So my exponent here is a 1, so I'll go ahead and put 1 in the numerator. The radical is the denominator, so I have 1/12. And I'm multiplying this by d, and then I have my fraction. Exponent is my numerator, 7. Radical, the denominator, 3. Add the fractions together. So I'm going to add 1/12 plus 7/3. And then look for a common denominator. 12 and 3. 12 and 3 are not the same, so I do not have a common denominator here, so I need to find one. Looking at this problem, I always start with the bigger denominator and figure out, can I make the smaller one into the bigger one? Is there something I can multiply 3 by to make it 12? And in this case, the answer is yes. I can multiply 3 by 4, and that will make the denominators the same, which means my first fraction stays the same. It already has a denominator of 12, so I don't need to multiply it by anything. But I do need to multiply the second fraction. I need to multiply both the top and the bottom by 4. So my 1/12 stays the same, and I'm going to add to that. Now, multiply both of these. So 7 times 4 is 28 over 3 times 4 is 12. Now my denominators are the same, okay? Once you get the same denominator, then you can go ahead and add the numerators. So 1 plus 28 gives me 29/12. After you add them together, determine, can you simplify this fraction? Well, looking at this 29 and 12, there is no common divisor here, so this is going to be part of my answer, okay? If I can't simplify, don't. So d stays the same, that's my letter, and then my exponent becomes 29/12. So that's our solution for problem number 3. For problem number 4, we have the square root of k to the 3rd times the square root of k to the 11th. So step 1, write these as rational exponents. So k comes down, and then I need a fraction. The exponent is the numerator. So 3 goes at the top. Now remember, any radical that doesn't have a number out front is the square root, okay? So if it's the square root, that means there's a 2 out there, they just didn't write it. So I'm going to go ahead and write it in, and that's going to be my denominator, okay? And both of these, we're missing the roots on the outside, so both of them would have a 2 on the outside. So my first one is k to the 3 halves, and I'm multiplying that by k, and then my fraction. 11 is the exponent, so it goes at the top. 2 is the radical, so that goes at the bottom. So 11 halves. Our next step, we need to add the fractions. So 3 halves plus 11 halves. Now, I'm looking for a common denominator. And the nice thing is, our denominator is 2 for both of these, so I already have a common denominator, so I can go ahead and add the numerators together. So 3 plus 11 is 14, and my denominator stays the same, 2. Now, 14 over 2, I can simplify that, right? 14 divided by 2 is 7, so I can divide that straight up. I don't have to have an exponent for my answer, or excuse me, a fraction for my answer, okay? 7 is going to be our exponent. There is no fraction. That's fine, right? It doesn't have to be a fraction every single time. So our answer is k to the 7th power for problem number 4. For problem number 5, we have the 6th root of h to the 7th, and we're multiplying that by the 4th root of h to the 3rd. So the first step is to rewrite these radicals, okay? So we have h, and then we need a fraction for the exponent. Exponent here is a 7, so my numerator is 7. The radical is a 6, so my denominator is 6. So I have h to the 7th sixth, and I'm multiplying that by h, and then our fraction. Exponent at the top, so 3. Radical at the bottom, 4. So h to the 3/4. From there, we are supposed to add the exponents. So we're going to add 7/6 plus 3/4. And I need a common denominator, okay? 6 and 4 are not the same. So I always look at the bigger denominator and I think, is there something I can multiply 4 by to make it 6? The answer is not unless it's a decimal, and I don't want decimals, okay? So 6 is no good. So from there, I'm gonna think, okay, 6, well, if I do 6 times 2, that's 12. So 6 could become 12. Can 4 become 12? Yes, okay? If I multiply 4 by 3, I would get 12. So 12 is going to be my common denominator here, okay? So I'm gonna use 12, which means I have to multiply both fractions this time, all right? I need to get both of these to be 12. Neither one is 12, so you must multiply both. So our first fraction, to make 6 become 12, I need to multiply it by 2. So I'm going to multiply the numerator and denominator by 2. So 7 times 2 is 14. 6 times 2 is my 12, which is great. That's what I wanted. For the second fraction, I need my denominator to become 12. Well, it's a 4 this time, so I can multiply it by 2 because 2 times 4 is 8. That's no good. So I need to multiply 4 by 3 to make it 12, which means I must multiply the numerator and the denominator by 3. So 3 times 3 is 9 over 4 times 3 is 12. Now I can add them together because they have a common denominator. So 14 plus 9 is 23 over 12. My next step is to reduce if possible. So looking at these, 23 and 12, there is no common divisor. I cannot simplify 23 over 12, so I leave it. So my answer is going to be h to the 23/12 for problem number 5. Now, for problem number 6, we have the 8th root of w to the 9th, and we're multiplying that by the 12th root of w to the 5th. So step 1, rewrite the radicals, okay? W comes down, make these into rational exponents. So for our numerator, we're going to use 9, the exponent. For the denominator, we will use 8, the radical. And we're going to multiply that by W, and again, rational exponent. So for our numerator, we're going to use 5, the exponent, and 12, the radical, will be our denominator. So we have 9/8 and 5/12. Now I need to add those together, okay? So we have 9/8 plus 5/12, and then I'm supposed to figure out if I need a common denominator or not. Are they the same? Well, 8 and 12, no, those are not the same. So I need to get them to be the same. So looking at this problem, 12 is the bigger denominator. Something that multiplies by 8 to make it 12, there's no whole number that you can multiply 8 by to get 12. So 12 is not going to work. So then I multiply 12 times 2. Well, 12 times 2 is 24. So 12 can become 24. And now we check with 8. Can 8 become 24? Yes. Okay, we would have to multiply that by 3. So that's exactly what I'm going to do. I'm going to multiply my numerator and denominator here by 3. So 9 times 3 gives me 27, and 8 times 3 gives me the 24 that I wanted. Now my second fraction, 5/12, I have to multiply that as well, okay? Because 12 is not 24, and 24 is my common denominator, so I need to go ahead and multiply top and bottom by 2, so I get the common denominator of 24. So 5 times 2 is 10, and 12 times 2 gives me the 24 that I want. Now that I have a common denominator, I can add them together. So 27 plus 10 is 37 over 24. And then I'm supposed to reduce if possible. Well, 37 and 24 don't have a common divisor, so I can't reduce these. So now I need to write my answer as an exponent. So W comes down, and my exponent is going to be 37/24. So that's our solution for problem number 6. At this time, go ahead and pause the video, try problems 7 and 8 on your own, and then restart the video and check your answer with mine. For problem number 7, we have the 9th root of p to the 8th power, and we're multiplying that by the 3rd root of p to the 7th. So the first thing I did was rewrite my radicals as rational exponents, which gave me p to the 8/9, again, exponent in the numerator, radical in the denominator, and I multiplied that by p to the 7/3, exponent, numerator, radical, denominator. From there, I added my fractions together, 8/9 plus 7/3. 9 and 3 are not the same, so I needed to get a common denominator, and I did find that 3 could become 9, so I only multiplied my second fraction. I left my first fraction as 8/9. I multiplied the second fraction by 3, and I got 21/9. That way the denominators are now the same, and then I went ahead and added them together. So 8 plus 21 gave me 29/9. 29 over 9 cannot be simplified, so I went ahead and wrote my answer as p to the 29/9. For problem number 8, we have the 6th root of j times the 10th root of j to the 3rd. First step was to rewrite those as rational exponents. Now remember, any letter that doesn't have an exponent, there is a 1 there, they just didn't write it. So my fraction became 1/6 for the first term, okay? And I'm multiplying that by j to the 3/10, exponent over radical, which means I need to add my two fractions, so I have 1/6 plus 3/10. 6 and 10 are not the same, so I had to find a common denominator. Now, 6 cannot become 10, all right, by multiplying by a whole number, so then I counted up from there. 10 times 2 is 20, so I tried 20, but 6 cannot become 20 by multiplying by a whole number. So then I did 10 times 3. 10 times 3 is 30, and 6 could become 30, so 30 is the one that I used, which means I multiply the first fraction by 5, because 6 times 5 gave me 30, 1 times 5 gave me 5. Second fraction, I had to multiply by 3 to get my denominator to be 30. So 10 times 3 gave me the 30, and 3 times 3 is 9. Once I got a common denominator, I could add the fractions together. So 5 plus 9 gave me 14, and I kept the denominator the same, 30. At this point, I noticed 14 and 30 are both even numbers, and even numbers are always divisible by 2. So I divided the numerator and denominator by 2 to simplify. So 14 divided by 2 gave me 7. 30 divided by 2 gave me 15. You cannot simplify 7 over 15, so my answer is j to the 7/15. And that's the end of our lesson on multiplying radicals.